right. So just for the sake of time again, we'll go over the solution, but we won't necessarily stop and do all the code reading. But let me turn off my Slack sound here. Close Slack on this laptop. There you go. All right. So we actually, in this exercise, you can see that we imported Bootstrap. So a lot of these classes that you're seeing right here, these are all Bootstrap classes. If you, I guess, just wanted to do some reading and kind of get an idea of how Bootstrap classes work, you can take a look here. But that's why all these classes look the way that they do. It's just because we're utilizing that Bootstrap library. Yeah.
What does the bootstrap thing means?
It gives us utility classes. So you can see what I'm doing right here is I'm linking Bootstrap CSS file. So we can see right here, the link, and we can see href bootstrap.min.css, right? So I'm importing Bootstrap CSS file, which is how I can then apply the styling of all these classes. So since I imported Bootstrap CSS, now when I give something a call 12, I have the CSS that would apply the styles to that class inside of that Bootstrap CSS file.
Oh, so it gives like a functionality.
It gives us classes that I can then use.
Then you can use like yeah, for styling. So it's like
Exactly.
What properties we can use.
It gives us classes that we use to apply those different CSS properties. So that when I give something a text center class, it will apply the property text align center.
Of the bootstrap.
Yeah. Awesome. So all we have here is we just have a form. So this whole exercise, we had these to-dos, and then in that form, we could input some of those to-dos, mark off the state, save them. But we have a form. Inside of that form, we have the one input, which we typed in all of our to-dos. And then we had our submit button that we would click on once we actually wanted to go and then submit or add those to-dos. And then we also had a UL, and this is where we're appending all of our tasks that we create via the form. So as soon as we create a to-do, we'll render that DOM tree, and then we'll append it to the UL right here. So this is where we're appending all of our DOM elements that we're creating in JavaScript. Yeah.
Sorry,
Huh?
I just started. Oh, never mind. I'll go back when you finish. Sorry.
Yes, no.
Because in the main TS, I saw that in the little stars, there is written the li class list group item. So is this like a way to note for us what this below code will do?
This is a comment. So this is a multi-line comment. So what I did is this DOM tree rendered to do generates this.
Yes.
So I just left a comment so that I know what the DOM structure of this would look like.
Okay.
It's essentially, it's like, if you remember Code Journal, you remember how on the view page, how I made you create it first manually in your HTML, and then I had to create the render function for it. So it gives me a way of, rather than having to switch back and forth between my HTML and my JavaScript file to know what DOM tree I want, I just created a comment so that I can easily refer back to it, so that I know as I'm writing this code, I could see the structure of what I want to build right there.
Right.
Yeah.
Okay, I just noticed. Thank
Yeah.
you.
Huh?
Is this the storage homework or this?
Yeah, the local storage exercise. Yep. So we have our UL, which we're appending all of our newly created to-dos. And then down here, we can see we have two different script tags. We have a script tag, which is loading in our data file. And then we have a script tag, which is loading in our main.js file. Once you get to the senior side, you're going to be learning about these things called imports and exports. And that is essentially one way of importing things from one file into another. But as far as right now, what we do is we have multiple script tags, but we need to make sure that the order of those script tags are correct. So in this case, I need to make sure that data is before main, because I want all of the code in data to run before all of the code inside of my main.js. I may also be utilizing some variables that exist in data.js inside of main.js. So in order for me to access variables from this file, I need to make sure that that file is ran first. So that's why the order does matter. Make sure the data file goes first. But so for this exercise, we had two different files. We had a data.ts file and we also had a main.ts file. The whole purpose of the data.ts file is to handle everything related to our local storage or our data, essentially. It's responsible for setting to local storage. It's responsible for reading from local storage. Just anything related to our data model goes inside of this file. So this is kind of a small preview of how we're starting to kind of break things up, right? Where we kind of break things up into multiple files. So rather than have one giant main.ts file that has all of my logic, I can kind of only go and only work with the code or the part of that functionality of the app kind of in that one file. So now I know if I ever need to change anything related to my data model, my local storage, it's all going to be inside of this one file. So I now just only need to go and update it in data.ts. I don't need to find where in main.ts, find the exact function and whatnot. So just breaking it up. So we created an interface for to-do. This is going to say what the to-do object is going to look like. So once I create a task, we're going to create an object, and this is going to be the properties that will exist in that object. So each to-do is going to give an ID. So that way I have a unique identifier for each to-do. We'll have a task, which is just going to be a string of what I actually typed into that input. So what is the actual to-do? And then it'll have an is completed status that is going to keep track of whether or not I've marked it as complete. So as soon as I click on that checkbox and then I mark the to-do as done or I don't, the is completed is essentially marking if I've completed my to-do or not. So the first thing we do is I create a to-dos variable and I assign it the result of read to-dos. So whatever read to-dos is going to return is going to get assigned to my to-dos variable. So what does read to-dos do? Well, first, what read to-dos is going to do is it's going to check local storage. So it's going to go to local storage and it's going to check to see if I've saved anything to local storage with this key. I'll pull up local storage in a little bit and we'll see it actually in the DevTools. But when you save something to local storage, you're saving a key value pair. So you're saving a key or kind of like a property in an object, a key, and then what the value is of this key. So I'm saving or I'm trying to access the to-do storage key inside of local storage. The next thing I do is I check to see if it actually existed. Was there something in local storage that had that key? Was it able to actually find that thing in local storage? If it was, then that means that I have a JSON string because I've saved something in local storage. So what I want to do is I want to convert it back into its original data structure. So if there was something in my local storage, then what I'm going to do is I'm going to parse it. So I convert it from the JSON string back into its original form, which in this case is going to be an array of objects. And then we are now going to return that array of objects. So now since I did to-dos equals read to-dos, as long as there was something in my local storage, then we are going to return those parsed to-dos. Yeah.
Yes, I was wondering, because I was thinking about the step-by-step, how the code is going to be read. And then I was thinking, so first we actually have to write something in the local storage for there to be there something, and then we read it.
Yep.
But then the function write to-dos, is it the todos that's in the stringify value? Is that showing each task?
Yes, and so to-dos is an array of objects. So I have an array and each object is each to-do. So to-dos is storing all of my to-dos. It's an array of all of my to-do objects.
And that's why it's assigned the value of the red.
That's why it's
Read
assigned.
to-dos.
Oh, no, right. So right here,
Being assigned.
this is trying to get something from local storage. So my code runs. The first thing I want to do is, has the user been here before? So I'm gonna call read to-dos. If the user has been here before, there will be something in local storage.
Oh.
So we grab what's in local storage and then we assign it. But if the user has never been here before, it's the first time they're on the page, then to-dos JSON won't exist. So what do? Is I return an empty array. So I'm creating the default data structure. Have they been here before? Then return their existing data structure. Is this their first time? Then create the default state of their data structure. So that's what the read to-dos is doing. It's handling both. Has the user been here before? Then return what the last state of it was. Otherwise, is it their first time? Then let's create the new data structure. Does that make sense?
Yes.
Awesome. Any questions about this file? Then let's check out the main.cs. So a lot of this code was already provided for you. The only thing you needed to do is you needed to add these write to-dos functions. So we think about it, I kind of have two different data structures. I have my local to-dos variable, but I also have local storage, right? So I'm saving some stuff in local storage, but I'm also saving things to to-dos. I want to make sure that they stay in sync, because that way, if a user refreshes the page, I want to make sure that local storage is also saving whatever the current state of their to-do is. So, since inside of my code, I'm using to-dos to access all of our current to-dos, whenever to-dos gets updated, I also need to update local storage. So that way I keep them in sync. So if I add a new to-do to my to-dos array, that will exist locally in this variable, but it will not exist in local storage yet. So I need to also update local storage so that anytime I ever update to-dos, local storage gets updated in case the user wants to be able to pick up where they left off. So anytime we ever update to-dos, I need to call write to-dos. So that way it will always stringify the current state of my to-dos, and it'll set it to local storage. So inside of our main, we query for our form. We then listened for the submit event on our form. Event.prevent default. So we refresh the page from reloading. We access our form elements. And then I create a to-do object. I gave it an ID. This is just a randomly generated ID. I'm just calling a function that's just generating a whole bunch of random letters and characters to give it an ID. I then access the value of the input. So I'm accessing what the user actually typed into the input via the form elements.task.value. And since they're creating the to-do, that means that it won't be completed because they're creating it. So they haven't marked it as complete or not. So I set the default state of is completed to false because they're creating the to-do. Okay? Yeah.
Yeah, no, so you said this one, the UUID v4, this one, you created this function, right?
No, this is a package that I'm using to do it for me.
The one with the CSS you said.
Not with CSS, no. This is an NPM package that I'm using. We'll learn about it in a couple weeks, so I don't really want to spend time getting into it. We'll learn about it. I'm just calling a function that generates an ID. That's all it's doing.
Oh, so it's like related to the local storage homework, right?
No,
We're gonna do
no,
the same thing?
No. I mean, it's just, I want to give each to do an ID, so I have a unique way of knowing which ID is what, right? All this is doing is it's just making sure to always generate a unique one.
So
I could have done this manually. All I did is someone created a package that already did that work. So I'm just using that package to do that portion.
So calling the function to return the type every time.
To return the value. So if I call UUID
Oh, it's a key
4,
value, yeah, key
it's
value.
like if I'm just giving it
Yeah.
something like that.
Scrolling.
It's just
Oh, wow.
generating a random string
That's
every single time.
My calling function. Wow. Never seen this.
Okay, so I create the object for the to-do. So once I actually submit, I create my to-do object. I then push that to-do to my to-dos array. So I have my to-dos, which is an array of objects. It's an array of objects that match my to-do interface. So whenever I create a new to-do, well, I need to push it to my to-dos variable because this is where we're storing all of our to-dos. Well, now I've pushed to my to-dos variable, but local storage hasn't been updated yet. So now if I were to refresh the page, I wouldn't have my new to-do because it doesn't exist in local storage yet. It only existed in my local variable. So what do I need to do? I also need to update local storage. So anytime I ever manipulate my data model, which in this case is to-dos, I also need to update local storage. So since I'm pushing to do, I updated my data model. I need to update local storage. So that's why I had to call write to-dos. So anytime we ever manipulate to-dos, you also need to call write to-dos. So right after it, I call write to-dos, which will take the current state of my to-dos array, which will have the new object. It'll stringify it, and then it'll set it to local storage. So now my data models are in sync. So now my local to-dos variable has the exact same content as my local storage. I then want to show the new to-do on the web page. So I call my render to-do function, and I pass in that to-do object. That's what this function's doing. So you can see render to do is going to be receiving one parameter, which will be a to do, and it's returning an HTML li element. As I was talking about with Caroline a bit earlier, I added a comment here just so I can easily see what this function is generating. So I already know all of the DOM elements. I know what class is. I know everything I need to give it. So that way, as I was writing it, I can just scroll up and I already kind of know the parent-child relationship and the hierarchy. I don't have to kind of go back and forth between my HTML file. So I just kind of added a comment here. So that way, as I was writing it, it helped me to easily know what to give it. But also, in case other people come and read my code, they can also kind of see what this will generate. This right here, this is referred to as a JS doc comment. So obviously comments are personalized. Everyone has their own way of how they like to leave comments or to write comments. This is kind of a generally accepted way of writing comments. So each team or company may have their own way that they would like for you to structure your comments. This is JS doc. So this is one way of writing comments. So these usually get added before every function to kind of talk about what the function is going to do. So you can see right here, the first little portion is a quick little summary of what the function does. So I can see it generates the DOM structure for task item. So it just gives a brief little synopsis of what the function's doing. I then tell it what parameters the function's going to be receiving. So it's going to be receiving one parameter called to do. Well, what is that parameter? It's the data for that task item. And then what is the actual function returns? It returns the DOM structure for the task item. So if you're looking for a, I guess, quote unquote, right way or quote unquote, best way to leave comments, this is one generally accepted way that some people will leave comments. They're called JS doc comments, and they are used as kind of a way of documentation. So I'm documenting what this function is actually going to go ahead and do. So now anytime someone else ever reads my code or they're working on this project, they can read this comment and then they can get an idea of how that function's actually going to be working. One of the cool things about these kind of comments too, is that it actually gets built into VS Code. So you can see when I hover over render to do, you can see my comments are right there. So we can see generates DOM structure for task item.
That's awesome.
So it literally took what I wrote as my summary and it added it right there for me. At param to do, the data for the task item. You can see it's literally taking whatever I wrote as the comment. If I were to, let's see, do we have another function where I can showcase the?
I used to do like a comment and then a line, put
Uh-huh.
then like the old way,
Yeah,
and then comment. This called the JS.comment,
JS doc, yep.
JS doc.
Yeah, so right here, you can see I created a function. I didn't add any of those comments. And you can see it doesn't really give me any of the other additional information, right? If I were to, let's go back and we just copy this easily, add it right before. So right now, I don't see anything next to add. I just see all the any's because I haven't typed anything. Now we can see as soon as I added that comment, well, now it added all of that stuff.
So
Right
it's like a
underneath.
// 2 stars, and then
Yeah, I'll send a link out. It's just the JS doc comments.
and star, and
Yeah, this is what it is. I'll send the
and you need to put the at thing.
yes. When you're talking about the individual portions, at param, at
At.
returns.
I was wondering
Huh?
about the data TS. In the data TS, so we completed the interface of to do, but then in the main TS, we actually wrote it in the event listener function for the submit button.
Uh-huh.
And the actual object is being created in the callback function in the.
Yes, so the
submit.
object gets created right here. Yep.
This is where it's created.
Mhm.
So anytime we want to say something to local storage of an input,
Uh-huh.
then we have to create the object. But then we have to push that off, we have to set that object into the to-do storage.
In this case,
What is the, sorry, the to-do
Nothing.
storage?
Uh-huh.
Like, we will have our own name for our local storage for our particular website,
your own name, what do you mean by your own name for
the
local storage?
to-do storage, because here
Yes,
we
yeah,
have.
you can call this whatever you want. So this is just a key. You can call it just whatever string you want. It doesn't need to be,
Is it somewhere, the to-do storage, is it somewhere in the HTML or no?
no. It's just
No.
a string that you're
It's just a
creating.
string that I named.
Yeah, so when you, if you open up a website, we'll go over this and we'll look at ours. Local storage, you can see all local storage saves is it saves keys and values. So when you set to do storage, you can see how there's one key right here that says debug. You're gonna have a key that says TypeScript local storage or to do storage, and then the value will be right here.
Oh,
This key can be called whatever you want. It's just how you're going to access that thing in local storage.
oh,
So it's just like an object, right? I can call the property whatever I want, but whatever that property is named, in order to access that value, I have to access that individual property.
uh-huh. See.
Any other questions?
I was just, can you talk a little bit more about how the flow is
Yeah.
like of the data and then how it moves through? Because I just now realized that the data has to be above the main TS in the HTML,
Yep.
even for it to read. So now it makes sense that first the computer will read the data TS and
Mhm.
then the main TS. So
Yep.
we have to write the code in this way.
Yep. So let me add debuggers to the top of both of our JavaScript files.
Let's see.
Okay. So in my HTML, I have two script tags. I have one for my data file and I have one for my main file. Let's open this up. And clear my local storage, so that way we're working from a fresh slate.
It's like a new thing, local storage.
No. I'll move these cameras. Okay, so I have two script tags. I have. Accidentally get rid of my other one. Oh, no, it's right. Wonder why I can't see. But I have two script tags. I have one for my data file and I have one for my main file. So since data is first, data is gonna get rendered and loaded first. So the first thing that's gonna happen is we're going to call read to dos. Okay. Well, what read to dos is gonna do is it's gonna check to see if in local storage, it has a to-do storage key. So it's gonna go over to my local storage and it's gonna say, is there anything in local storage? In this case, there is not, because it's my first time going to the web page. So to-dos JSON is going to be false because it has a value of null. So I cannot do JSON parse to-dos JSON because it's null. So I just create the initial structure of my variable, which is just going to be an empty array. So in theory, eventually, I'm going to be storing an array of objects, but since there's nothing in local storage right now, because I haven't created any to-dos, I don't have any objects, so I'm just going to create the array. So I'm just going to assign an empty array to my to-dos variable. Now we can see to-dos is an array and it's empty. Yep. Run all that. And now all the code inside of my main.js is going to run. So now it's going to go and it's going to create all of my event listeners, all my variables. And now my function has finished running all of that. Okay. Now let's create a to-do. So let's add a debugger there, or a breakpoint. Now let's say I need to drink water. As soon as I hit enter or I hit add, my debugger should get caught right here on line 6. All right, here we are. So I just hit add. So I just fired my submit event listener because I just had my submit button. I refreshed or prevent the page from refreshing or reloading. I access all of the elements that existed in to-do forms. So this is how I'm getting access to all my form controls. So I'm getting access to my inputs. I create my to-do object. So I'm going to give it a randomly generated ID. I'm going to access the input from my form elements. You can see it's been highlighted. I'm going to access the value so that I'm able to see what the user actually typed into the input, which is going to be drink water.
I see it there.
And since I haven't crossed it off because I'm creating it, I set the is completed state to false because I have not marked that task as done. So the object has now been completed. So are created. So now I have one to-do object. It has all the information related to that to-do. You see it has a randomly generated ID, it has the task, and it has that is completed state. Well, now the next thing I need to do is I need to add it to my to-dos array. So we will push the current to-do object that we just created into our to-dos array, which is currently empty. So now we added our to-do object to our to-dos array. So now,
Even though it was in the data TS file, even though it was over there, we
Yes.
still wrote it down.
yep, because since my data file was loaded first, that variable was already created.
Okay.
Because in data.ts, I created a to-dos variable right here, right? Since this code ran first, that variable has already been created. Since it's not in any functions, it's in the global space, which is how I'm able to access it inside of main.ts. So now when I call, I have access to to-dos because data file already ran.
Okay.
But now my data model has been updated. So you can see when I log to-dos, I have my new object, but local storage, I still don't have anything. So I updated my local data model, but I haven't updated local storage yet. So now the next thing I want to do is I want to update local storage. So we'll now call write to-dos. Write to-dos is going to take the current state of my to-dos, which is an array of objects. It's going to stringify it. So now to-dos JSON, we can see is a JSON string. And now I'm going to be saving something to local storage. So now I will be saving that JSON string and I will be saving it with the key to do storage. You can see right now, I currently do not have anything in local storage. Soon as that line of code runs, and now you can see I've saved something in local storage now. And it now has that key of to do storage, and then it has that value. We'll move back on. Well, now I've created the to-do. Well, now I need to be able to show the to-do on the page. So I need to render it. So I will now take the object that we just created, pass it into my render to-do function. And this is going to allow me to actually generate this to-do. So it's going to generate the content in that comment, the li, that div, the input. So it's going to generate all of those elements, give it the classes, give it the values and text content. It's going to return our outermost element, since the li is a parent to everything. It has all those children. I return the li, which is going to return the whole tree. I take the return value of render to do, which is an li element, and I append that to my to-do list. So right now, my UL is completely empty. I do not have any to-dos. So now I'm going to take the current one that gets rendered, and I'm going to append it to that UL. So I'll move on. And now we can see the to-do has been added to the page. And now in my UL, we can see it has that li. So now I actually added it to the web page. Now I need to reset the form. It still has what I typed into the input. Well, the user's already submitted something. So now I need to reset the form. So now I will reset the form. The input got reset. And now my code is done. And now I've created the to-do. Now, let's say I refresh the page. Okay. I refresh the page. Well, I want to pull all of the data that I had the last time that I ran the page. So now what am I going to do? Well, I'm going to call read to-dos. What is read to-dos going to do? It's going to go check local storage, and it's going to check to see if there's something in local storage that has a key called to-do storage. Well, in my local storage, I do have a key called to-do storage. So now my code is going to go access that key in local storage. It's going to take what's being assigned to its value, and then that is what's going to be assigned to to-dos JSON. So right now we can see the value is this array of objects. As soon as I move on to the next line, when I hover over to-dos JSON, we can see it's that JSON string of my array of objects that we just pulled from local storage. Well, now I want to check to see, was there something that I actually found in local storage? In this case, there was. So to-dos JSON is true. So now I'm going to parse that JSON. So convert it from a JSON string back into the array of objects. So that's what will get returned. So now my to-dos variable is an array of objects that we just pulled from local storage. Okay.
Why did you have to pull this from local storage? And why did the drink water to-do disappear from the list? Because you refreshed the page. Then why
Well,
is
I
it
need to pull from
important?
local storage because local storage is the only way that I can persist data between re-renders.
Persist data between reruns?
Yes.
I don't understand that.
Okay. So
Different way.
when I was saving drink water, right?
Uh-huh.
Where does this exist?
In the local storage.
Okay, besides local storage.
I don't know. In the variable.
In the variable to-dos.
Oh, I'm doing that like physical.
Okay. So if I didn't save anything in local storage, what would I assign to to-dos when it gets created?
An array of objects.
Okay, but how do I keep the object from the last time I was on the page?
And save it into.
I need local storage. Because as soon as someone refreshes the page, what's gonna happen? They're gonna rerun all of my code. Well, if I do not have something in local storage, this is gonna be false, right? Which means I always return an empty array. So I'm always gonna have an empty array. So there is no way for me to ever save data between a refresh if I do not use some other outside way of saving that data, which is why I need local storage. I do not have a way in my code to be able to save it. So I need to save it somewhere else so that when my code gets ran again, I can go search that outside place to now pull it back in. Yeah.
Thank you.
Any questions about the flow of the local storage?
So pretty much the idea, just want to get the idea so I can understand the problem. So it's pretty much, we are the local storage is like a pretty much like a server, just.
Think about it, it's kind of like a
Not like a
database in the browser.
So we're just interacting, sending a data to a database, storing it. So whenever it's refreshed or anything happen, we can retrieve.
Yes, local storage will always stay until someone resets their local storage.
Oh, so this is why it's called persisting the data.
Yes, because that data is persisting. It's staying between the re-renders. So data, as soon as I save something in local storage, that data is always going to stay there until either I were to go in and manually clear my local storage. So it's like, I'm not sure if you ever like a website's not working or something, and then you like refresh your cookies and like refresh your cache. But when you refresh your cookies and when you refresh your cache, you're gonna clear out like all of
The local storage.
Exactly, which is
Oh.
why it can fix some of those weird finicky behaviors. Because if you have some data that was saved from a old version of the website, and now they made updates to that version of the website, the data that you've saved from the last time you were there, there's like some weird differences. And so they'll say reset your cache or reset your cookies so that way you kind of clear out all of the existing data.
The cache is like a memory pretty much. So,
Yeah.
Also, this is why we are using JSON, so we can make it like a small, this is why it's lightweight, it's a string, and it's sent to the local storage and
Yes.
stored as a string.
The local storage can only store JSON. It's the only thing it can store.
Oh.
So that's why I cannot just assign an object to local storage. I have to assign a JSON string to local storage. It cannot save anything else except a JSON string or a string, but more specifically, we'll use it with JSON strings.
So pretty much like if you want like to imagine a real world problem. So imagine like you're on a website and as JavaScript to do, you put like a drinking water, you put like a ad, and this is gonna be sent to the database, for
Mhm.
example. And then I refresh the page, but the data still persists.
Yes.
stored in- And then if I wanna we make like another like input area to put like a retrieve, like a button retrieve data. So I hit retrieve data, so it's gonna
Go to the database.
and go to database and retrieve the data.
Yep.
And okay.
Yeah, so it's like right now, we are only on the front end. We don't
Uh-huh.
have a server, we don't have a database. So since I do not have a database, I don't have a way of persisting my data between the rebranders. So the only way that we
Local
know of
storage.
as of right now is local storage.
To persist the
Yeah.
data. Okay.
Yeah.
And
And that data is local to that page. So the local storage for LearningFuze.com is different than the local storage for Google.com. So you're only saving the storage for that website.
this is why we're gonna use a database like a Postgres. We're gonna use SQL. We're gonna use right?
Yeah, I mean, we'll use a database because, I mean, you don't want to save things in local storage because then it's only local to that one machine, but also to that one browser.
Uh-huh.
So like my to-dos right here only exist on Arc on this laptop. If I were to go to my laptop right there, and if I were to go to this page, I wouldn't have the same data because that has a whole different local storage. A database, you want to use a database because all of your data is all related. I don't want you to have different data than Caroline. All of your data is still together. So local storage is you're not going to save your whole application's storage in local storage. It's just bits and pieces. So like an example of where I use local storage on a project is I built this like anime website thing where you can like review or watch or find different animes. But I have a theme toggler. So I have a light theme and a dark theme. And what I'm using local storage is I'm using it to save your preference. So based off of whatever theme you used last, that's the theme that I show you the next time. So if you were on light theme and then you refresh the page, they'll stay in light theme. If you were on dark theme, and now you'll stay on dark theme. So if we were to check the local storage, well, you can see I'm storing a key called theme, and I stored a value called dark. If I change it, you can see I changed it to light. So I'm using it to store one of your preferences so I know which theme to essentially show you. So this is an example of where you might use local storage. I wouldn't store all the users that have created an account on my website on local storage. I would store that in a database. But little user preferences that only depend on you, you may save stuff like that on local storage.
So this is why we have like a mini database, like a AWS, we have this, we have this, we have like a.
Well, every
Cloud.
database is different.
Is
You
this
have
like-
relational databases, you have non-relational databases, even within relational databases, you have databases that do different things. Why are there hundreds of different programming languages? They all serve different purposes. Why are there hundreds of thousands of different cars? They all serve different purposes, you know, so it's like there may be some consistencies or things that they all do, but each language, each thing serves a different purpose. Each database serves a different purpose.
Can I ask you just one last question? I'm sorry, I'm asking you a
Mhm.
question. The previous assignment, there's like a weird behavior of the JSON and object, so. So when you parse, when you create the JSON student, for example, and you put it inside a string. So when you want to do JSON.parse, to parse the student, return it back to object, you don't have to create interface, just create, it's kind of weird.
You never have to create an interface. You
Right.
should create interfaces. TypeScript has type inference. So based off of whatever you assign to a variable, it's able to figure out what the data type is. So if you assigned an object directly to a variable, it already typed the object for you. But you should still create an interface because what if I need to use that type multiple places? By having an interface will allow me to do that.
Because that is what I've done.
Well, yeah, but watch, so watch. I'll create an object and let's do it in TypeScript.
And assign it to the.
Okay. I created a person object. I gave it a name property. I gave it an age property. Now I'm trying to add an occupation property. Property occupation does not exist on type.
So it created, oh wow, so it
So
created.
this is what I'm saying. TypeScript has type inference. So based off of whatever you assign to a variable, TypeScript is already able to infer the types based off of what you assign. So TypeScript already knows that this is an object whose name property is a string and whose age property is a number. But now if I ever needed to reuse person, like let's say this returned a person array, well, I don't have an interface now to be able to reuse that. Now I would have to recreate it. So that's why I want to create an interface. So you don't technically need to, but anytime you ever create an object, it's good practice to also create an interface for the object.
So it's a structure to every object. But it's automatically knows TypeScript.
TypeScript will infer the type as long as it can. If you call a function, like in this case, I set the function's return type to do array. So since the function's return type is to do array, so TypeScript knows that if I assign something to do, it's already going to be a to do array. because I typed read to-dos, return type as to-dos array. So TypeScript's already able to put it together. Yeah.
And TypeScript knows that the to-do with the brackets for the array is the return type for the to-do.
Because I put it right here.
Because you put it right there in the read.
So read to-dos is gonna return an array of objects that match to-do. So to-dos, since this is gonna be what it returns, that's also gonna be the type of this.
It's interesting that we didn't have to put it in the interface,
Which one in the
the
interface?
array.
Inside of here, but the array is not a part of this. The array is storing this.
Oh, that's
This is
right.
inside the array. The array is not inside the object. The objects are inside the array. So I'm saying this is an array of objects that match to-dos. Yeah. Take a look at our quiz questions. So Noah, can you tell me, how can I store data in local storage?
You're gonna store the data by stringify the data and send it back to the local server.
Do you know what method is used to save something in local storage?
Dot, so we're gonna put the variable name dot items.
No, so it's set item. So there's a local storage object, you'll use the local storage object and then set item, and that's how you'll save something in local storage. So you'll use the set item method. So the set item method, you'll give it a key, you'll give it a value, and then that is how you can save something to local storage. Trey, how can I retrieve data from local storage?
You use the get item method, so it'd be get item and then the key with type of whatever string you created.
Yeah, exactly. So we'll use the get item method, and then you'll pass in a string that will correlate to whatever key it is that you're trying to pull from local storage.
What was it again? So we
So the get item method.
get item method.
Yeah, so local storage dot get item, and you pass in a string of what key you're trying to select from local storage.
So we got the key to get the value.
Yeah, so if we open up the local storage is a collection of keys, values. So you'll have a key that you'll use to actually access what's being saved in local storage.
So it's yeah, this is an actual database. Hash data.
Rakaya, what data type can local storage save in the browser?
String.
Strings, yeah, strings. And then Caroline, when is the safest time to store user data?
Form submissions or after validation is successful.
I would say. Let me give
When
you,
the server confirms the data was received. After any client-side data processing is complete.
all of that's true. I would say in simple terms, whenever the user modifies the data. So in this case, as soon as the user created a to-do, I also updated local storage, right? So basically, I would say the answer is the safest time to store user data is whenever they modify. So whenever they change their data. Right? It's like you go to your settings page on like Facebook or whatever, you change a setting in there, you want to save it immediately. So whenever the user modifies the data, that's the best time to save it. So in our case, the user added a to-do, since we pushed it right here, then we save local storage. Anytime we ever modify our data model, we'll also update local storage at the same time. Awesome. Any final questions about local storage?
Oh wow, so this kind of give us like a kind of a sample of the back end. How we're gonna.
It's not a sample of the back end. The back end is going to work in a very different way. It's just from a front end only perspective.
Front-end, sorry,
This is
front-end.
one of the only ways of how I can actually save data
Here.
in a front end only application. There's local storage. There's also session storage. Session storage is only for that session. So like while I'm on the web page, as soon as I were to close that tab, then the session's done and I would lose everything in session storage.
Get that pop-up on the website, it says your session is about to expire.
Yeah.
If you're buying like a ticket of some
Yeah.
sort.
So usually definitely like banks, like anything with sensitive information, because they don't want you to just leave your computer on so that anyone can access it or whatever. So they may like terminate the session early or whatever, but that's essentially the difference is local storage will always stay until someone would actually clear their local storage. Whereas in session storage will only stay for the session, only while the user is on that specific website.
It's a key value and.
Any final questions about local storage? Yeah.
So this is why the storage are object too, so because they have a key value, pretty much.
Yeah. We're all good? All right. Well then, let's go over what the rest of the week is going to entail. So let me stop